Hi everyone, and welcome to the session on Azure AI Fundamentals. Appreciate you guys are taking your time to join us and learn more about Azure AI. And yeah, the session will be 2 day session, which we will go through most of the AI fundamentals concepts, and this is going to be 1.5 hour 12 session, which we'll be having the same tomorrow as well. For the today's session, we have our special guest Anupama, who is a Microsoft MVP and who is a Microsoft MCT as well. And I would like to welcome her to session. And yeah, before I move the mic to Anubama and getting started, I wanted to explain a few things about today's session. That is, the session is going to be recorded and will be available in our YouTube channel if you want to, go around and watch it again. And secondly, there is certificate of participation which you can get at the end of session, which is tomorrow, and be sure to fill it out to receive your certificate of participation. You don't need to worry about it during the session. We'll make sure everybody who joins us will receive your certificate of participation. And yeah, any questions or queries, you can drop it in the chat box, and I'll be here there to respond to you. Okay, without any more delay, we can get into the session, and I'm moving the mic to Anupama to introduce herself more and getting started to the session. Over to you, Anupama.
Thanks, Rug, and thanks everyone for joining the session around Azure AI Fundamentals. So, I'm quite excited about this topic because artificial intelligence has been a big buzzword in the IT sector for last few years, and so everyone would be keen to know about AI. And of course, even I was like a few years ago when it was started, and now more around the generative AI, the Chat GPT, and all those buzzwords again we are hearing, and what opportunities that it is bringing to the IT industry, and especially to all the industries that we have got across the world. So just to before we get started with the Azure AI fundamentals, and as you know, this is really a fundamental session. So if you are new to AI, or if you are not sure about what AI is really is, especially in the context of Azure, then you are at the right session, because this is going to be the level 100, I would say, like really fundamental basics that we will be going through in today's session as well as in tomorrow's session. Pretty much, I'm going to cover topics that are related with AI 900 certification. So the advantage of attending this session is like post attending this session, you will have an opportunity like where you can, if you want, go and take up the AI 900 certification. And mainly the reason I was talking about is like sometimes like having getting this knowledge, you don't want to waste it, right? If you want to really make use of it, then you can just take up the AI 900 certification, and I will give you some tips and tricks around how do you prepare for the certification after this session, and also like take this as an opportunity and go and book the exam and take up the exam also. So before we get into the session, a little bit of introduction about myself. I'm Anupama Natarajan, and I'm a data and AI consultant from Wellington, New Zealand. So I have 20 plus years of experience working in the IT industry, and pretty much like my experience comes from like pretty much I started my career as a developer, but always I'm data focused. So when it comes to data, it's more around I used to design uh, transactional models for applications, but eventually in the last decade or so, I was more interested in getting value out of the data for my business customers. So pretty much I started doing analytics reporting, and how can we extract uh, like more or less like like important information out of data, so that the businesses can make like critical decisions based on that. And I love to expose the data, especially in the way whichever format the businesses are interested in. So it doesn't mean like I won't say like I'll be doing only reporting or I'll do only analytics. If I can expose the data in the form of APIs, happy to do that. If I can use the data in order to enrich like a customer experience using bots, I'm interested in doing that. And now more in the generative AI space. So how do we use the data and get value out of that? And that's what I'm very much passionate about. So you have an opportunity today. If you have any questions, feel free to put that in the chat window. I know like we have a lot of participants. I'll be periodically jumping on the chat window just to see what type of questions that are coming around, and especially around technical stuff, and then I'll be able to answer it. You also have an opportunity you to ask any questions even tomorrow, because I'll be available again for running the tomorrow session. And if you have any questions, feel free to reach out to me. If you have any questions, post today's session or tomorrow's session, especially when you are trying to prepare for the certification. I'm available on the social media channels. So you can feel free to reach out to me. Uh, If you have any questions and anything that needs to be clarified, I'm happy to do so. So you have my Twitter handle, my LinkedIn profile, as well as my email address on the website. Feel free to reach out to me if you have any questions post today and tomorrow's session. And of course, I'm a Microsoft certified trainer and a Microsoft MVP for data and AI. Cool. So, what are we going to cover off as part of today's session? So, in terms of the agenda, we are going to look at the fundamentals. So, when I talk about the fundamentals, like everything that we are going to discuss, all the topics is all going to be fundamentals. So, we'll be looking at the fundamentals around artificial intelligence. We'll look at the fundamentals around machine learning, and we will go a little bit around computer vision today, but I think pretty much a lot will be covered in tomorrow's session, and also around natural language processing. So, what are all these things? Where does it fit in? And what is this all AI is all about? And how organizations can embrace AI. So, do we need to kickstart a new project? So, if we suddenly want to start AI in our organization, how do we get going with that? So I'll be talking about that all. And the interesting thing I will also add in my presentation is I'll give you some real world perspectives. So it's not going to be just examples talking about like, okay, this is what you can do with AI, but also some real world customer examples, like where AI has been pretty much used in order to just help business users and industries to achieve better outcomes. So we will be touching upon those use cases also as we go along different topics. Cool. So let me quickly jump onto my other slide. Just bear with me. Okay, so the first and foremost we are going to look at is the fundamentals of artificial intelligence. So what is AI really is all about? So we'll be looking at a quick introduction to what artificial intelligence is, and then how do we use artificial intelligence in the context of Microsoft Azure. So that's what pretty much we are going to look at as part of this particular topic. So my understanding is some of you would have got an introduction to AI, someone would be new to AI. So I'll keep everyone in the mind, and then I will talk about AI in a nutshell. So what is AI is all about? So when we talk about AI, basically like we are looking at software that imitates human capabilities. So, like I can do certain things, right? So, if I teach a machine to do that, and if the machine can do that by learning from me, then that's what we call it as artificial intelligence. So, this can be in terms of like predicting outcomes and recognizing patterns based on historical data. So, to give you a simple example about that, right? So, suppose like you have an ice cream shop, right? And this ice cream shop, you used to sell ice creams irrespective of their seasons. So whether it's a summer or a winter, it doesn't matter. You still have the ice cream shop. uh, you need to know about like when do you want to stock the ice cream. So when do you want to like have more in stock, and when do you want to just order less in stock. So how do you go about doing that? You have to look for some sort of patterns, right? So how often people are buying ice creams, and so you can't go based on just one attribute saying like, okay, this month in January people have bought ice creams, more ice cream. So probably I'll go with the assumption I'll stock it up equally in February or March or something. So how do you make that decision? So do you overstock it? Do you understock it? Like how do you make that call? And that's where like artificial intelligence will come and help you. So basically, like you take data, historical data. So suppose if you take last year's worth of data in terms of ice cream sales, and you can plot it over to say like on a monthly basis, and also then you know exactly the seasons, because I have participants here from different parts of the world, and I'm not going to say, but I'll take the perspective of New Zealand. In New Zealand, it is currently winter time. So us eating ice creams in winter is not that much. So when you look at the seasonal times, like when you take the season into account with the ice cream sales, normally during the months of March, April, May, June, July, August, September, up to I would say end of September, the ice cream sales will be less. But from September, October onwards, like it's summertime for us, so pretty much like the ice cream sales will be more because it's going to be quite sunny, and you will be having one or two or even three ice creams in a particular day, and so on. So that what it really shows, like basically like there are many factors that can influence in terms of in our example it's the ice cream sales, right? So how do we know like how these seasonal patterns and the sales of the ice cream will help you to predict how much you want to stock for the future? It's because of the learning from your historical data. So you go and pull the data from last 2 years, and then you can make the call to say, yes, I can see during the summer season, I can see more amount of ice cream sales than what I could see in winter time. So that's something like you can use your historic data in order to predict the future. So this is just one example, right? There are a lot of other real world examples where you can really use the data in order to predict. Like rainfall is a classic example. So when you can use the historical data and you can just look around like, okay, this is the time when these symptoms happen, when this is the pressure, water pressure we have, or the air pressure that we have got, we used to get the rain. So you can predict and forecast a lot of things. The other thing is in terms of is like recognizing abnormal events and making decisions based on that. Suppose like a classic example is like when you are doing online trading, right? So for online trading, normally like you will be looking at what is the price that is currently happening, so I can make a decision on whether I want to buy certain things, or I don't want to sell certain things at that time. And suppose like if you see a pattern where the price was like going in terms of like, okay, it was $100 and suddenly it went to $50 and then $200. All of a sudden, if you notice, like suddenly the price spiked up to $5,000 in the data. And suppose if you're analyzing that data, like you want to be notified immediately about like, oh, there is some sort of abnormality in the data because the price was gradually fluctuating, but all of a sudden you see a huge amount of fluctuation up to $5,000. That's what we call it as abnormal data. And this can happen a lot, whether we are talking about online trading or even with financial transactions. So all of a sudden you may find abnormal transaction that has been happening. For instance, all the transactions for the last hour has been happening in New Zealand, and after in 1 hour's time, there is a transaction happening on the same card in US. How can that happen? Did someone travel to New Zealand from New Zealand to US in 1 hour time? And especially that is coming from an IP address from there. So these are what we call it as abnormal events that can happen. And AI is really good in terms of capturing those abnormal events so that we can handle that. And also like one of the cool thing about AI, which we will be talking a lot in tomorrow's session, is around natural language processing. So when I want to explain someone about natural language processing, I always start with this simple example. I love coffee. So I drink coffee on a daily basis, and especially during winter time, I love to go to work by getting a coffee and then going to work. And so normally I have this pattern, like I have the I get the coffee at my train station, and then I catch the train and go to work. So when I go on when I went to this like cafe at my train station for the first time, I have to go there and I have to tell them like I would like to have a regular flat white, and it's a takeaway with two sugars. And the second day when I went there, and I had to say regular flat white, same thing like takeaway with 2 sugars. But then subsequently, because I get into this pattern of ordering the same type of coffee every day, so the person knows like that's what exactly like I will be just ordering. So what it was really good is like so the person recognized me. As soon as they recognized me after a week or so, pretty much they were able to know that I'm ordering a flat white, and they just give me the flat white. That's it. So why I'm telling this as an example is like after looking at this pattern, which is the behavior of me buying a coffee every day, and when bot framework was released by Microsoft, me and my friend we decided let us sit down and build a bot. And the idea that came to my mind is I order coffee every day. Like, why can't we just build a bot for my the cafe that is where I buy the coffee, so I can just order online through the bot through to them, and then they can prepare the coffee ready for me, and I can come and collect it. So me and my friend, when we were working through the bot, one thing that we had was uh, my friend designed the interface where it asked for what is the type of coffee you want. Do you want it to have here or take away? And so do you want to have it with do you want sugar with your coffee, and how many, what is the quantity of sugar you require, and is it a large size or a regular size of coffee that you want? So then the bot was given to me for testing purposes. They said, my friend said, like, Anupama, come on, use the bot and see what you feel about it. The first time I was so excited because it asked the right questions and I was able to provide the relevant answers. But subsequently, like second time, third time, fourth time, it kept on asking the same question. I kept on answering that, and I got bored. And I said, like, this is getting monotonous here, because when I went to the cafe, at least 3 times or 4 times they asked me. But after that, they were able to remember my face. And as soon as I go there, I don't need to even say anything. They'll say flat white, 2 sugars, and then they will make the coffee for me. But the bot is not clever enough. And that's when we started looking at, okay, so how do we make a bot to behave like a human? That's where natural language processing comes into play. So the bot should be able to understand how a human speaks. So if I'm asking for a coffee at a cafe, I'll be saying I need a regular flat white with 2 sugars, and that's it. And so that's basically in that one sentence it says what is the coffee type I need, and then what is the size of my coffee, and also like whether I need sugar or not, and how many quantities of sugar I require. So all this information is in that one sentence, right? So the bot should be capable of when a human says that, the bot should be capable of extracting that information, or whether they say or whether they type doesn't matter. And that's what natural language processing is. So when initially like bot frameworks were introduced, a lot of there were a lot of websites where we went to where it said, oh, we will be able to automatically create the bot. Building a bot is easy, but building an intelligent bot is not that easy. So when we talk about natural language processing tomorrow, we will talk a bit more about that. And last but not the least is extracting information from the sources that you have got to gain the knowledge. A lot of organizations collect a whole heap of data. And what do they do with the data? Not much. When I gave you my introduction, one thing I was mentioning about is I love to extract value out of the data for my businesses. And that's exactly AI will help you to do. So, how you can get valuable information that can be shared with your business users so that they can gain a lot of knowledge about their own data. And that's what some of the things that AI can really do for your organization. So, in a nutshell, like what you can basically understand is how AI is revolutionizing things, because you will be able to do a lot of things in terms of like automating human behaviors and capabilities. So some of the common artificial intelligence workloads I really wanted to talk about is we'll start with machine learning. So everyone have this question to say like, is AI and machine learning are the same, or are they really different? And what is the difference between them? So if I talk about machine learning is a foundation for most of the AI solutions. So if you talk about AI solutions and things, I would say like machine learning is a subset of AI. It's not a replacement of AI or anything. So it is a subset of AI. So how does machine learning basically work? So in today's world, we capture a lot of data, right? So huge volumes of data, whether the data comes in text messages, emails, social media posts, images, videos that we take on our phones. So we generate ourselves a massive amount of information. And also like apart from that, if you're looking at, I'm not sure like how many of you have noticed it, pretty much like every single appliance I'm using in my house comes with an app. And like starting from like even the lights I put in my house, like they have got an app installed. The air coolers that I have in my house has got app available. So all these are generating the data. And if you look at a lot of commercial organizations and things, they have sensors, and all these sensors are pretty much generating large volumes of data. So when we talk about data generation, data is getting generated almost everywhere. And what historically used to happen is like we used to have data scientists who will sit there, analyze the data, and they will look at like some patterns in the data so that they can make predictions using that data. So for instance, if I want to give you an example, right? So if I want to use machine learning as a capability, normally what I can do is like the ice cream example, which I told, analyze the historical data and predict what is going to be the sales. Another thing is around like if you want to sell a car, right? So normally like you want to predict the price for a car. So whether you buy a car or sell a car, like a price prediction is one of the common thing. Car is buying and selling a car is just an example, but this can be applicable for buying anything like insurance products, like banking products. So you will be looking at opportunities in terms of and even eligibility for loan approvals, whether you will be able to get a loan or not. So all these things can be predicted using machine learning. The first and foremost criteria is machine learning cannot solve all the problems. So keep that in mind, because you can't use machine learning for the sake of just let me use machine learning. So you need to identify the right problem and whether it can be solved by machine learning. Then the next thing is, have you got the right data? Because machine learning is all about predicting the future using the data from the past. So if you don't have large volumes of data, then probably I'm not going to say you can't do machine learning, but your predictions may not be that accurate. So you can still start doing machine learning, but you need to start looking at accumulating the data as you go along. And yes, at certain point, once you have enough data, then you can start trusting your models, and there will be more confidence in your models in terms of prediction. But until then, if you don't have large volumes of data, that is the step you need to go through. But if you have large volumes of data, then probably you will have more confidence and comfortableness with your predictions that you're making with machine learning. So again, this is the important aspect that you need to understand. So large organizations, like they used to have data scientists who could do machine learning. But what about like now there are a lot of use cases that can be solved with the machine learning, but we didn't have a lot of resources like data scientists who can do that. So that's where Microsoft made machine learning much more easier. So how can we provide the tools to the organization so that they can do the machine learning in a much more easier way? And what Microsoft did was like they actually implemented machine learning services on Azure, so which allowed them in order to just build some of the machine learning capabilities. So let me quickly jump onto the Azure portal. I'm not sure how many of you have seen the Azure portal before. Because it's a fundamentals, I hope you would have attended an Azure fundamental before the session. If not, I'll briefly introduce you to the Azure portal, and then we will look into the AI services within Azure. So Microsoft Azure is one of the cloud platform, as you know. Of course, you have AWS and GCP, Google Cloud Platform. But Azure stands out mainly for enterprises because with Microsoft Azure, they take security seriously and they have got a lot of compliance and certifications, which a lot of organizations look for in terms of whether they can host their data on a cloud platform, that whether that is a trusted cloud platform or not. So cloud, one of the question that people normally ask me is around um, like where machine learning, why it is a buzzword only in the recent years. So have machine learning been done in historically? So the answer for that question is yes. So machine learning has been done historically. So it's not that we are the first people or we are the first generation where machine learning is getting done. So but then why it wasn't a buzzword in those days? So I'll give you a simple example from my career, right? So 20 plus years of experience. So I have seen a lot of things in my career. So when I was working with, I would say like 10 or 15 years ago, so I have seen organizations doing predictions. So they used to predict prices, they used to do all the sorts of predictions. But when I look at what is the technology that they have been using, is they built their models using VB macros. So this is VBA code that they write in order to build their machine learning models. The another fundamental thing I also looked at is uh, where do they, what is the infrastructure that they use to run these models? Normally, there will be one or two data scientists in the organization, and the data scientists, they will be having a grunty server that will be running under their desk. So I have literally seen this in my experience. So they will be running, and they are pretty much like secured the server. The server, that particular server alone doesn't sit with the IT team at all. It will be sitting with the business. And if you look at that, it will have huge volumes of RAM and storage capacity. And it is really an expensive server, and it won't have any backups. And if something crashes, like they don't worry about it because it's all managed within the business users. And they use that to run their predictions and models. So the reason why I'm saying that is because this is how they have been doing machine learning. And of course, they make predictions. But at any point in time, if I ask them to say, like, okay, can you recreate that model, what you did 3 months ago? They will struggle because they don't have the capacity to hold all the data that they have used for training the model. They can't do version control. And so they will be always having only the latest. At any point in time, if you ask them to go back and regenerate it, it was not going to give them the same results. It will be totally giving them a different set of results. So when, what happens when you have this type of things? There is won't be any trust, right? So they will be saying, we can use it for assumptions, but there is no confidence in that models. And that's what cloud changed. So when cloud was introduced to people, like one of the things that with cloud brought in is like this elasticity and the scalability. So you, if you need a higher capacity, whether it's a storage, whether it's memory, or whether it's a CPUs, it's available. And it's available for the duration of how long that you need. So you don't need storage like if you don't need storage, you need only like 100 gigs today, and then tomorrow like you don't need it and you want to get it back to 50 gig, you can scale it down. And if you need 200 gig, you can scale it up. That was quite easier. And also like it is more the operational cost for organizations, right? Because they are not going to invest in infrastructure upfront. So it is more or less as they go along, as they discover that they need more infrastructure, they are going to invest on that. That is one of the reason why AI has come back as a buzzword these days, because now you have the infrastructure, now you have the tools, now you have the ability to version everything. So because storage is not a problem anymore, so you can version the data that was used to create the model, version the models. So which means at any point in time you will be able to recreate the model with the data that was used at that point in time in order to achieve the same results. So the reason for doing that is if you do that, the confidence in your model increases, which means the adoption is going to be naturally increasing. And that's what has happened with the AI more recently, is because of the cloud providing all those capabilities. Now they can do AI in a much more confident way. So coming back to Azure. So Azure, this is basically the Azure portal. normally you can navigate to the Azure portal using portal.azure.com. So if you are a new user and you don't have any Azure subscriptions, Azure provides you the capability where you can sign up for a free subscription. So you can go and sign up on for Azure for free, and you will get a subscription that you can use. It comes with, I think, around $200 credits. And also, like, I would say, like, it's a $200 credits that you can use, and either you like use the services for those $200 credits. That should be fine. And of course, like, if you are learning about Azure, I think I will share some links towards either today or tomorrow, where you can go and practice them using a sandbox environment. So the sandbox environment is free, and you can try a few things using the sandbox environment without any issues. Cool. So this is my Azure portal, and I have created what I call it as a resource group called AI 900. A resource group is nothing but keep that like a folder or a container. Okay. So normally when you want to put all your files together, you create a folder, right? Similarly in Azure, I want to put all my resources together for my project. So this is a AI 900 project that I'm going to do for you. So I want to make sure all the resources I create or need to be stored in that project. And that's what a resource group is. It's basically a container to hold all my resources. So that's what I have created here. The next thing you can do is if you want to create any AI related resources, normally I can go and hit on create. And this is going to take me to what I call it as the Azure Marketplace. So this is basically the marketplace. Like normally when you go for a marketplace, you can purchase things, right? Similarly, in the Azure Marketplace, you can look for products. So here I have a catalog, or what we call it as categories. So if you can look at the categories here, one of the thing I have got is the AI and the machine learning category. So here I should be able to see all the things around AI and machine learning services that are available on Azure for me to provision. So that's what we call it as a marketplace. One second, I'll just share something. Just give me a sec. Okay, so what I was telling you was like that you can get a free account with Azure. So I'll just quickly share the link. Just bear with me. Cool. So the link I'm going to give you where you can go ahead and create your free Azure account if you need, and make a note of it. There are certain services that are available for free. And so you need to just look at what services that you're trying to provision, whether it is covered as part of the free subscription, and you can use it. But that's the link that you can use to create your free Azure account. But shortly, I will also share some of the sandbox environments where you can practice some of the AI related labs for free. Cool. So this is my marketplace. And so here I'm going to go and provision Azure Machine Learning. Don't worry about that. This is just for your, I'm not going to delve detail into, go into detail about Azure Machine Learning, but it's mainly just to let you know, like, you get a feel of like, what does this machine learning platform looks like. So I'm going to uh, create a ML 2023. I'm just giving a name for my machine learning workspace. I use my Australia East data center. And there you go. So I'll just go ahead and create a machine learning workspace. The cool thing about Azure platform is if you want to create a resource, it's really straightforward. Go and fill in some details, decide on which resource you want to create. And in some cases, like you need to look at the pricing, saying, okay, if I'm provisioning a VM or something, then I need to know how much I need to pay. And then probably it will go ahead and start deploying the resource for you. And once the resource has been deployed, then you can start utilizing it. So here, what I'm doing is I'm creating a machine learning resource. So when I say machine learning resource, there are quite a few resources that will get created. And one of the resource is basically the Machine Learning Studio. So Machine Learning Studio is a UI interface that I will be able to use in order to create my machine learning models. So in a nutshell, that is sufficient enough for you to know as part of the fundamentals. So I'll just wait and come back to this once the machine learning studio interface is created and ready. So in the meantime, let us look at some of the other aspects of machine learning. So what we have been looking at. Okay, so we looked at machine learning. I'm going to start talking about anomaly detection. Suppose like if you are working in a bank, right, and you have to create a software system where you would like to monitor credit card transactions and also detect any unusual usage patterns that may indicate like a fraud. So exactly where I was talking about, right, where I've been having transactions for the past 1 hour in New Zealand, and all of a sudden after 1 hour all the transactions are happening in US. So something is wrong. Someone has stolen the credit card details and making those transactions from US. So that's something you can do as part of the anomaly detection. And then another thing you can also look at is like you can collect a lot of telemetry information on devices. So if you look at like one of our clients, they used to have wind turbines. So wind turbines used to generate the energy for these utilities companies, and what we had to know is like these wind turbines are not something that is available for us to go and see every day, but we will have sensors and everything on those wind turbines so that we will know like exactly whether all the parts that are associated with the wind turbine they are working fine, or whether it is anything that is due for so basically, like it is whether anything is due for a service or something, I will be able to see that as part of the wind turbine, and I can schedule for predictive maintenance. So normally maintenance used to be like, oh, when there is a fault, you go and find out, oh, it looks like we need to do some maintenance on the wind turbine. Rather than if I use machine learning, probably I can do it in a more proactive fashion. And also with anomaly detection, sometimes you can start looking at the mission starting to behave in a different way. And that's another indication to say whether it requires a service. So anomaly is something like, okay, things used to run normally. And if things are not running normally, and if we are able to detect that scenario, then basically that's where anomaly detection can be really valuable. So again, anomaly detection is also like the way how you can look at things and you can just fix them accordingly. I think our Azure service, machine learning service is ready. Let me pull that through. So once the resource is created, this is what you will get to see. If we go to the resource, so this is my machine learning workspace that got created. So if I go and launch my machine learning studio, so basically now I will be able to create machine learning models using this interface. Cool. So I have got multiple ways how I can create machine learning studios. So one of the thing, if you look at it, is like I can say notebooks. I can see automated ML. I have a designer. And of course, I have a prompt flow. So I won't talk about much of prompt flow for now, but I'll talk about the notebooks, automated ML, and designer. I'll talk about prompt flow when we talk about generative AI. When I say notebooks, suppose like if you have data scientists in your organization, right? They will be pretty good in writing Python code. So starting from collecting the data, cleansing the data, transforming the data, and creating a model, machine learning model, and then testing, training the model, testing the model, and deploying the model. They would like to do, which is basically all these steps which I was talking about. We call it as a ML workflow or a machine learning workflow. So collecting, getting the data, transforming the data, then you will be using the data to create a model. You train the model, you test the model, you deploy the model. And this is going to be an iterative process. So machine learning is not just a one-off activity. You'll be continuously doing as new data is coming through. You will keep on checking whether your model is still giving the right results. The point I'm trying to make here is like this used to be done. So if you want to do the end-to-end machine learning workflow using Python, where I'm going to write Python code starting to extract data, cleanse, transform, create a machine learning model, train, test, and deploy. Everything will be done in Python. Then probably you will be using notebooks for that, and which a lot of data scientists they are comfortable with because they would love to write Python code in order to do the machine learning workflow. And if you are a user like that, then notebooks would be your choice. Where does automated ML fits in? So suppose if you're like me, right? So I was a software developer and then I got into and suddenly I want to become an ML engineer, right? So if I have to do become an ML engineer, I'm not going to become like get a data scientist certification or anything. So what I basically need is like I need the ability, so where I will be want to create the machine learning models, but I want an easy way to create machine learning models. And that's where automated ML comes into play. So automated ML, when Microsoft were thinking about how do we make machine learning easy for organizations? Because not a lot of organizations have got a lot of data scientists, and it is not a skill that you can easily train and get them ready. So Microsoft wanted to give tools that will help organizations to build machine learning models with the capabilities that they have already got. So what they did was like they identified there are some common machine learning problems that are available, which is consistent across different industries. Classic example I told you is price prediction. So price prediction is not just going to be one industry because I may buy a car or I may buy a fridge or I may buy a TV. So price prediction is going to be consistent. So you want to buy a product and you want to predict the price for the product based on the features you get. So today an LED TV with these features may cost me $5,000, or tomorrow with an additional advance or quantum technology and things I may, or a OLED stuff I may get $10,000. So a 45-inch television may cost this much versus a 75-inch television may cost this much. So there are various parameters that is going to detect the pricing, right? How do you detect do price predictions and across the different industries? So the theme is common. What are we going to, the problem is we need to predict a price, and the factors that are going to contribute for the price prediction. For car it will be different set of attributes, for a television it will be different set of attributes. Similarly every product, like if I want to purchase a credit card package or something, that will be a different set of attributes that will determine the price. But because like there is a common theme here, the common problem and a set of factors deciding that, that is a good candidate for automated ML. So what Microsoft did was they created this tool called automated machine learning. So it is a wizard like interface. You feed in some data, you will like your historical data, you tell what you want to predict, and then you will tell what are the factors in your data that is going to influence your prediction. For instance, if I say if I want to predict the price of a car, the make, the model, the year it was manufactured, all those things play an important role, right? Similarly, you need to make sure that all the factors that is going to influence the prediction of the price, you provide that. Once you provide that, then automatically automated ML, it is going to spin up the VMs and it is going to pick the certain algorithms that is going to help with the price prediction. It is going to generate models in parallel. So sometimes it based on the data, the different type of models, it will come and different type of algorithms. It is going to give you 5 or 6 different models, and it will also rank all the models, and it will say this is the optimal model that you can use for your data set that you have got and the problem that you're trying to solve. So here, as a data scientist, I don't need to do anything. So I need to feed the data, put the configuration parameters, what I require, and then pretty much wait for automated machine learning to provide that. And of course, the data is going to be trained and we will be testing it. So you will have that confidence level also with the data. And each of this model come that is generated with automated ML, they are going to be explainable. So you will be able to explain why one model is better than the other. So long story short, automated ML simplifies your model development process. And if you are a user like me, so if it is not a complex problem, it is a common problem across the industries, automated ML is your first bet to go with. But sometimes, as I told you, not all the problems can be solved using automated ML. So in that case, the next fallback you have got is the using ML designer, or what we call it as a designer. So the ML designer is basically a graphical user interface where you can drag and drop and create a machine learning model. You don't need to write any code. So you can either use notebooks, which is writing code from scratch in Python, or automated ML, where you can feed in the data and the parameters, and it is going to generate the model for you, or your designer, which is basically you drag and drop and you can do the configuration without writing any code, and you can generate a machine learning model. So this is the capability automated machine, like your Azure machine learning actually provides you. The three ways of how you can create machine learning models. But when I talked to you, I said to you, machine learning requires grunty machines, and we need the ability to version the data, version the models. Everything is encompassed in this interface. So you can create data assets, you can create jobs, and you can also create compute in here. So I can create computing clusters. So I can go and say what type of virtual machine I want for running my machine learning models, and you can provision it and so on. So basically, all the problems that I highlighted to you historically that we had in terms of storage, compute, it's all been resolved now, and version control, they're all been resolved now, and it is available in here. So there is a question here. What is different about Azure AI platform and Microsoft Fabric, which got released recently? As I know, I could do data science process on Fabric also. Yes, that's right. So you will be, if you have an existing model that you have created with Azure Machine Learning, you can use that model in Fabric. Or if you are, because when I say Fabric is basically, think about, you want to build a modern data warehouse platform for your organization, which includes end to end, starting to collect the data, transform the data, build a data warehouse, and then you enhance the data using machine learning capabilities, and then you expose the data via using Power BI reports or dashboards. And sometimes what happens is people already have a data warehouse. And or people may already have a lot of machine learning models created in Azure Machine Learning. So what now you can do is if you're building your warehouse in Fabric, you'll be able to incorporate the machine learning models that you generated in Azure Machine Learning and use it. So it's basically the Fabric is a service that is integrating a wider range of Azure services for building your enterprise data platform, basically, which includes your machine learning capabilities also. So if you ask me the question, do I need to go to Fabric to create a machine learning model? No. If your objective is just to create machine learning model, not an enterprise data warehouse platform or anything, go and use Azure Machine Learning, build your models. But if your intention is I need an enterprise data warehouse platform, along with I need to infuse the uh, machine learning capabilities to that, yes, of course, you can go with Fabric. Hopefully that makes sense in terms of when do you use what. Okay, so getting back to our slides here. So the next one I need to talk about is computer vision. So we talked about anomaly detection. So computer vision is like how much value that nowadays we can get with our images, the videos, the audios that we capture. And so it's pretty cool. And I will also talk about a real world scenario where we used this. So first thing is the images, right? So with the AI and especially the computer vision, we are able to extract information about a image. So let me explain this with a quick example. So let me quickly show you some demos related to computer vision so that you can able to relate to that. So here is my computer vision. Just to zoom that a bit. So one of the thing I can do here is I can select an image, and this is behind the scenes applying computer vision, and I'll talk about what it is. It automatically, when you provide an image, it will automatically extract the tags associated with the image, a description, and also like you can try any other image like that. So if I choose this particular image, it is going to say a yellow car on the street, and it gives me the confidence level, and also tells me does this image has got any adult content or racy content or anything. The other option is this is done using computer vision. Similarly, if you have an image which has got text, it can extract the text out of that, and this is really valuable, right? And if I have handwritten information in an image, it can extract the text out of the handwritten information. And if I have an image which has got a celebrity or a landmark, it will automatically find that out. So this is a Statue of Liberty. So it knows it is a landmark, and it gave me a 95% confidence level. Basically, when I have a 95% confidence level, I can trust and I can go with it. I don't need to go and manually go and check for that. So similarly, if you look at this, this is the Golden Gate Bridge. It has been already with 100% confident, it has detected it. And if you take Microsoft CEO, it has detected even your celebrities. And not only this, but also like computer vision is capable of detecting logos based on like the brands. So if you have a Nike logo or a Microsoft logo in an image, it can automatically detect that. And I had a lot of examples like that, which I was playing with computer vision. And one such example I wanted to really talk about is let me quickly show you some examples before I jump onto the use case. Yeah, so some things that you can basically do with so if you want to extract like do thumbnails of your stuff, right, you can easily do thumbnails. So you can take an image and you can basically say, I need to crop this image into a thumbnail. It will automatically will do that. So when we talk about computer vision can do a lot of things. And when we it can describe an image, you can provide an image, and you can just basically see an output that it is going to tell like what is the image basically says. And also it is going to give a confidence level for each and everything that it is predicting, because the higher the confidence level, you can use it with trust. The lower the confidence level, you may need to validate. And I'll also give you a rule of thumb how you will be going about doing that. So this is a classic one. So where if I have to extract any information, so for instance, I told you like identifying brands, it will detect if you upload an image, it will automatically detect the brand if it has, or if it is a landmark, it will be, and also including celebrities. So here I have a cricketer, Sachin Tendulkar, and it detected it, but also it detected like Sachin Tendulkar is a celebrity. So I'll be able to get the celebrity information. So you can see from the image, it has identified Sachin Tendulkar as a celebrity. Okay, so the reason I was talking about this before I wanted to give a real world example is, so this is all good. Like I upload an image, it is able to detect it. But how do I correlate it? How I can use it in a real world scenario? So we had this customer where they were looking at, they had, this is a power company, and they have got meters. So they have got new meters that they are rolling out to a lot of residential homes, but they also have what we call it as the old meters. So these old meters, the new meters are pretty good. So they can, from a centralized location, they will be exactly able to get the meter readings. But for the old meters, they have to physically send someone to the houses where they will note down the meter reading and stuff. The interesting thing is in some houses like the meters will be outside, and in some houses like the meters will be inside. which means like if the house, if no one is in the house, they will not be able to get the meter reading. So they have to come back, and what they normally do is they will go with the prediction. Okay, over the last 3 months, this is what their usage was, so they will go with that, and they will predict the power bill for the client. And normally for those clients, the customer had a lot of problems because the client comes back and said, no, this month I was away and I didn't use that much power, and this is what my meter reading is. Can you just update my billing? So this was getting a problem for them because more and more customers were not available when the meter readers are going and doing the meter reading. So they wanted to look at how they can use AI to solve this problem. So what they did was they had a set of images because all these old meters, they are of a certain like a brand. So they collected images of that. So they created a model where first thing is if you upload an image, it will look for whether it is part of any of these models and it will detect that. Then the second part is what they had the ability is the extracting the uh, meter reading from the image using OCR capability, and for which they used computer vision. So with the help of computer vision, they were able to, if someone sends them an image, they will be able to extract the meter reading straight out of the image. So they used this AI capability. They rolled out an app to the customers. So what the customer need to do is like they have to just take a photo of their meter, and then they have to send it to the utilities or the power company, and they will have a process where they extract the image, they extract the text out of the image, they direct the meter reading, and then automatically they will file it with the corresponding customer's account. So in that way they have reduced the amount of calls that they were getting at their call center, and also like reduce the amount of unhappy customers. So this is a real world use case where like the AI capabilities like custom vision and computer vision, they have been used in order to meet like better outcomes for customers. And also it simplified the work for the businesses because organizations they can use employees for more value added services rather than looking at so they don't need to even worry about sending people to get the meter readings. So they'll just say like the customers can do this as a self service capability. So that's a classic example. What are the things that you can really do with computer vision? Natural language processing, another common thing that AI can provide, where applications can interpret written or spoken languages and it can engage in dialogues with human users. And this is the classic thing I talked about, right? So you can build a bot and the bot can communicate with your user. What are the things that you can do with the bot? So it's not only the coffee bot, right? Like you can do a lot of ordering services using your the capabilities that you have got with the natural language processing service. Not only that, some of the things that you can also do with the natural language processing is okay. So now some of the other things that you can do with natural language processing is having improving the customer service. Again, a real world scenario, and this is with me as a customer. So I wasn't on the other side as a consultant. I was a customer. So I work 9 to 5 every day. And one of the thing is like when I go to work, I don't have time to think about my household activities, and which is pretty much a lot of people do. And even at lunchtime, like my focus is talking about some stuff, and then let me do all my household activities in the evening. So one of the thing that was causing me a lot of pain is my insurance renewal, because if every time when I want to do an insurance renewal, they haven't provided me a self-service capability. What they said is like, okay, go to this website, put your insurance number, and then it will tell you what is your amount, and this is your secret key or something, and then you can pay it, which is all good. But sometimes I have clarifications while I'm about to renew it saying, maybe my amount of like I bought a new TV or I have got more devices in my house. So now I need to increase my contents insurance. So probably I may need a device to quote before I renew it. So when I try to do that after 6 p.m. in the evening, there is no chance for me to get hold of anyone. So I used to think maybe first thing in the morning because the insurance company had their call center between 9 to 5. So I have to ring them first thing in the morning and I'll be thinking about it. But normally, I won't be able to just do that because I'll get busy with my work activities. And what happened is, after 6 months of what I was going through, giving feedback to this insurance company, they turned their like a call center to 24 by 7 instead of 9 to 5. And I was surprised, but what I was able to get that was like they introduced their chatbot. And the chatbot was like you would have thought about like how would, it would have solved the problem. Some of the common questions I had, the chatbot clarified it really well. Even when I wanted a quote or something, it collected all the details from me, and it said like a quote will be emailed to this is your email address, and it will be emailed to your email address. And the next day morning or evening when I have the time, I look at the quote, all good, talk to the chatbot and say confirm the quote, and then I just renew my insurance. So this avoided me waiting to wait for talking to an operator in order to do basic things like auto renewing my insurance and so on. So why I'm saying this is like natural language processing is helping. So I never felt like I was talking to a bot because I was an IT person. I was able to eventually figure that out. But pretty much the bot was trained in such a way, it was like as if I was talking or chatting with a human person. The other areas where I would say natural language processing is really good is in call center scenarios. So I have a scenario with a customer where the customer always takes calls about the call center always takes calls from the customers. So, and on average, they used to spend 15 minutes to talk with the customer, understand their problem, give them some recommendations and stuff, and finish the call. After every call, which is basically 15 minutes dealing with the customer, the next 15 minutes, the operator will not pick any calls. And I was surprised. I was like trying to understand what are they doing in the next 15 minutes. They basically summarize what was the conversation that they have been having with the previous customer in that call, and they will be updating their notes in their customer record. And so so what happens is for that 15 minutes, they won't pick any calls, which means like think about in this case, there are 50 operators. Each operator after 15 minutes, they spend next 15 minutes writing about what they discussed with that customer. So the customer wanted to have like a better way of handling how do we better improve this process using AI. So what we did for them is like while the conversation is happening between the operator and the customer, we basically started to transcript the conversation. So we captured the audio and then we also converted that into text. And automatically we started, once the conversation is finished, the transcript has automatically is sent to their customer record system, which is their CRM system, and it is added as the notes. So this is what they have been doing manually, but we used AI to automate that. So what it resulted is like for the 50 operators the customer had, so the 15 minutes of each of their operator time was saved, which means they were able to take much more better calls and provide service for their customers rather than spending their time writing notes about the previous conversation they had with the customer. So these are the advantages like how AI can facilitate organizations and get value, provide value for them. The last but not the least is knowledge mining. So basically like how can you extract knowledge out of the existing resources that you have got. And what you have got as a service on Azure is basically your cognitive search. So the cognitive search resource allows people to basically handle, so basically that they can get information out of their stuff that they have got. So to give you a simple example, right? So I have got this give you some example in here. Okay, so let me get this out. Cool. So this is a website that was built which with all the facts or information that they had around John Kennedy's assassination. So what you can do is you can look for any keyword related to the assassination of John Kennedy and you can search it. And the interesting thing is when we talk about search, historically what we used to search, like Word documents, PDF documents, websites, right? But with cognitive search, now you can go a next level. So you can search images, you can search handwritten information, you can search like audio files, you can search video files. So if you look at this example, like we are looking for the word or the person Oswald. So the Oswald person, like you, even if it is an image, and here it someone has uploaded the image. So this like alternate text, or what we call it as a description about the image, it was generated by cognitive search. And now this has got information in here around Oswald. So this is image of Oswald. So this is actually now coming as part of the search request. So as you can see here, whether it is documents or whether it is structured document, semi-structured document, or unstructured document, you will be able to extract that information with the help of cognitive search. And that is what we call it as knowledge mining. So now this the cognitive search has taken knowledge mining to the next level. So where now you will be able to extract information out of anything. So another interesting thing was like videos. So how much stuff that you can now extract with videos is like an audio file. So you can recognize the speaker who is in the audio file. Or one of the thing that it will also allow you to do is like at what point in the video, sometimes you may have a YouTube video like that can span for a hour, right? But if you want to see like at what point Oswald was speaking in that video, automatically you can jump to that part, and then Oswald was speaking only for 5 minutes in that video, or appeared only 5 minutes in that video, and you will get that you can directly go to that footage and you can have a look at it. That is the capability now you can get with the help of cognitive search, and that's how you can basically do knowledge mining. So these are some of the things that you can basically do with cognitive or like not cognitive, like basically artificial intelligence, machine learning, anomaly detection, computer vision, natural language processing, as well as knowledge mining. So now you understood the differences between each one of them, right? When I talk about like artificial intelligence, I will always talk about this topic, which is around responsible AI. So why responsible AI is really important? When we talk about artificial intelligence, because you can see how powerful AI can be. Because like if I say like it can do price predictions, it can tell me whether I get approval for a loan or not. So they all can be decided using my artificial intelligence or machine learning capabilities, which means we need to be careful in how we use the tool, right? Because otherwise it is going to introduce a lot of challenges or risks. Some of the challenges of risks can like it in terms of bias. So bias can affect your results. So what does that really mean? Suppose if you take a loan approval, you created a loan approval model, and what you have noticed is only the people who are male gender, they were getting loan approvals. Any female who is applying for a loan approval, their application is getting rejected because the model is biased towards only for males. How this can happen? Because if someone has used the training data, where pretty much all the training data it had the gender of male, so pretty much you will be creating a model where it will say, oh, if the gender is male, then automatically it is meeting the criteria, the model will approve it, because you haven't used the basically the variety of data that can decide on a particular loan approval. The other one is around reliability and safety, where sometimes errors can cause harm. So a classic example is autonomous vehicles. So autonomous vehicles is becoming more and more, where we are talking here about driverless vehicles and things. But if there is a fault, then probably like the harm is serious, because you can even lose a person life. So that is important to understand. Suppose like another thing is like we need a lot of data to train machine learning models within for artificial intelligence, right? So then in that case, like sometimes if, what happens if sensitive data gets exposed, which means like if you create a medical diagnostic bot, and if it is trained using sensitive data, then probably that is going to share that sensitive data with other people. some solutions may not work for everyone, because if you have people who are visually impaired, then you can't have an home automation with no audio output is going to help them. And users also need to trust a complex system, right? So if you are going to have a financial tool built with AI, so and if you are giving recommendations, the first thing that goes in their mind is, what are these recommendations based on? How do I trust that? And also, who is liable for AI driven decisions? So you can create a model and put that, is your organization responsible for the decisions that AI is creating? For instance, like if a person, innocent person, is convicted of a crime based on the evidence from facial recognition, who is responsible for that? So all these things are challenges and risk that AI can impose. And that's why what Microsoft did is they introduced these principles, what we call it as principles of responsible AI. And these are guided any AI development, even when they do within Microsoft, they follow these six principles. The first one is fairness. First thing is, AI systems should treat everyone fairly. So, as I said, if you have a loan approval application for a bank, make sure that the loan needs to approval should be done irrespective of any bias based on gender, ethnicity, or any factors. So, it has to be fair for all the applicants. The next one is reliability and safety. So AI based applications must be subjected for rigorous testing, and that is really important. So you need to test, and you need to have a proper management process in place to ensure that everything is going to work as expected before you release it. Privacy is security is another one. So AI system should be secure and it should respect privacy. So if certain data needs to be kept private, especially uh, like your patient information or your personal details, they need to be kept private, and also like there need to be security around that data so that the information is not leaked for other users. Inclusiveness is another one. So you have to include everyone. So as I told you, you have to the AI solution should work for everyone, irrespective of their physical ability, their gender, their sexual orientation, their ethnicity, or any other factors. So you can't say like, okay, the AI solution will work for only one set of users and not for the other set of users. And transparency is more important. So if you are saying like, I'm doing a loan approval model, and I use this model in order to predict whether a person is eligible for loan or not, you should be able to explain at any point in time how this model works, what criteria it takes into account. And at any point in time, the transparency is important. If someone comes and asks you to explain how your model works, you should be able to explain it. You can't just say, I'm not sure what the model does, but this is what the output is. Okay, so that's what transparency is. Last but not the least is accountability. So you need to make sure like people who are generating or creating the AI systems, they should work within a framework of governance and organizational principles so that the solution meets the ethical and legal standards. So that is really important. And that's why these six, what we call it as the responsible AI pillars, are really important. So the fairness, the reliability and safety, the privacy and security, inclusiveness, transparency, and accountability. So when you are taking your AI 900 exam, like when Microsoft asks you about responsible AI principles, these are the six principles we are talking about. Okay, so this is all good, but how do we do AI in Microsoft Azure? So that's the next part we are going to look at. So as I told you, I have already introduced you to the Azure basics in terms of the resource group and the resources that you can create. And like the key thing around why AI can be done on Azure is because of the data storage, the compute, and the services that it provides. And the different services that we have got in Microsoft Azure is Azure Machine Learning. This is a platform that you can use to build your machine learning models. And I also showcased that. The next one is cognitive services. So cognitive services is another resource that you can provision on Azure. And we talked about computer vision, anomaly detection. They are all part of the cognitive services. Azure Bot Service is another service where the Azure Bot Service will allow you to create bots. So if you want to create a chatbot to improve your customer service, then actually you will provision the Azure Bot Service and you will build your chatbot. Cognitive search, as I told you, like if you want to do knowledge mining and intelligent incorporate intelligent search capabilities where it can search on images, audio, and video, then cognitive search is the resource that you can provision. Last but not the least is the Azure Open AI. So this is a new service that has been introduced, and it is part of what we call it as generative AI. So you would have heard about Chat GPT a lot. So where I think if you want, you can start writing a code. It will do the code completion for you. So if you ask a question, it will automatically provide you an answer. So initially, like Open AI, it's basically they are a non-profit organization. They used to create this large models, machine learning models. And now what Microsoft done is they have partnered with Open AI so that they can Open AI can run their large data models on Azure platform, because you need the compute, right, to run your bigger models. And now with this collaboration between OpenAI and Azure, so now you can run your OpenAI models on Azure without any issues. So let me quickly demonstrate the OpenAI model so that you know what it does. And then probably I'll talk about the Azure OpenAI model a bit more in tomorrow's session. So let me quickly get into the OpenAI. Just give me a sec. Cool. So this is my Open AI, or like the Chat GPT model that I'm using. So this is not Microsoft Open AI, so or the Azure Open AI. Azure Open AI is something different. So this is here I'm going to really chat about, ask about something. Okay, write newsletter, or maybe write an email uh, letting the team know about the project XYZ success. So this is, I'm just asking ChatGPT to say like, okay, I want to write an email about for my team to know about the project XYZ success. So this is actually automatically started writing an email for me. So now I can take this email and then I can like make some changes, and basically I can go ahead and do that, whatever I need to do. So I can ask about any topics. Um, Write a summary about Azure Open AI. So if you can look at here, so basically it is going to write about Azure Open AI and things. So you can ask any questions to Chat GPT and it is going to give you responses if it has got information about that. And these responses are coming from the based on the large models that it has trained, and they have kept it in here. And so if I ask to say like, provide me, okay, so right, uh, give me some questions related to Azure Machine Learning. So here, if I want to prepare some questions, and sometimes you can even ask question and answers, it is going to give you the question and answers related to Azure Machine Learning. And now, like if you are like a lecturer or a teacher, these can be really handy so that you can prepare some questions that you can take it for your students the next day. So like this is what we call it as the generative AI, and where AI is taking its next step in terms of using large machine learning models. And now you can automate writing your code, or you can just generate new content quite easily. And so every time if you look at it, if I say regenerate the response, it is going to give me different set of questions. So the interesting thing is it's not going to cache the results. So every time when I'm asking regenerate the response, it is going to and bring me a different set of results. So that is something to keep in mind. So that is OpenAI, and Azure OpenAI is another service that you can provision on Azure where you can run these OpenAI models within the Azure infrastructure. So we talked about computer vision, right? Where the ability to extract information out of an image, and so then we also looked at the brands. We looked at like, okay, if it is a handwritten information, I can extract text out of that. If I have an image and I want to like make thumbnail of that, I'll be able to do that with computer vision. But how does computer vision work? So computer vision is part of the Azure Cognitive Services. So if I want to just quickly show you what an Azure Cognitive Service is, or how do you go about provision Azure Cognitive Services. So let me quickly get in there to my Azure portal. So I can go to my resource group and I click on create. So here I can go and say I want to provision a cognitive resource, cognitive services resource. And here you can say like, okay, so if you provision this resource, you will get access to compute like the vision, which is your computer vision, language, search, and speech services, all using a single API. So cognitive services is nothing but it is an API. So API is an application programming interface. So basically like it is a URL that you can connect to, and you give an image to the URL, and the URL is going to give you a response depending on what you're asking. Suppose if you say give me a thumbnail of an image, the URL is going to give you a thumbnail of the image as a response. So you have to send the request as your image and it is going to give you a response. I'm not sure whether you will be able to ask a question. I can see a hand being raised. So Surag, like, can they ask questions or do they need to put that in the chat?
They need to put in the chat.
Okay, so Rajan, like I have seen your hand being raised. If you can put your question in the chat, I should be able to respond to that. Cool. So that's what cognitive services is. The interesting thing about cognitive services is there are five different types of categories under which the cognitive services are available. So I have a few cognitive services under vision, few under language, which can do translations or from one language to another language, or you have the speech services where you can do text to speech, speech to text, and then you have got the search capabilities. Sometimes suppose in an example I was telling, right, so where I wanted for one of my customer, I have to use multiple cognitive services in a single solution. So I have to create a single solution and I have to use two different cognitive services together. So in that case, like I don't want to go and provision separate one for language, one for vision separately. So if I provision a cognitive services service, I can use other APIs within that. But sometimes if you are going to use only the vision, so you can go and look for computer vision as a service here. So now, if I'm going to use only computer vision, I can just provision that. But if I'm going to use more than one cognitive services in my solution, then probably I can provision a cognitive service resource and I can do that. So let us try provisioning the cognitive service resource. So let me go and provision this. And I'm going to give a name for my cognitive service. It is going to be Australia East in the region. And And then I'm going to go for a standard tire, and I'll say like because when you're training you will be uploading images, you're basically acknowledging like that you are complying to the responsible AI principles that Microsoft follows. And then I'm going to say review and create it. So now this is going to create my Azure Cognitive Services resource. Once this cognitive services resource is created, then there are two important things that I require. So because I told you like then you can send a URL image to a URL, then you whatever you ask for, whether a description or a thumbnail, it will be generated. But how do you know? How does Azure know like whom I'm going to charge? Because anyone can call this URL, right? How does it know like which is the Azure subscription I need to be charging? So there are a couple of things in order to you need in order to use this particular cognitive service. The first one is what we call it as endpoint. So this is the URL that you will be hitting, and this is going to clearly say you are going to hit the cog services 2023A, and it knows this belongs to my subscription. So when Azure is actually serving an output, it will automatically say, oh, it is going to charge me my subscription, whatever is involved in giving that response. The other one it requires is the keys. So basically this is like a grid or something. So having the endpoint and the key are important. So you need this is more specific to each subscription. So if you send these details along with the image, then automatically you will be getting a response. So that is something to understand how our cognitive services basically work. And we'll look at some examples in tomorrow's session, but in a nutshell, this is how cognitive services work. So if you have to use multiple cognitive services APIs in your solution, you provision a cognitive services resource. And that's why it is called as Azure AI Services multi-service account. Because if I provision it once, I can use multiple services within that. But if you want to just use computer vision API alone in your solution, and I'm not going to use any other cognitive services, then probably you can just provision, go and create a computer vision service itself. So that is the fundamental difference between when you provision a cognitive services resource versus when you provide provision a standalone resource. And that's important from an exam perspective to understand. So you provision a general cognitive services resource if you want to utilize multiple services, or you provision the standalone resource if you want to use only the specific services in your solution. And when you are using a cognitive services resource, there are two things that are really important. One is the REST endpoint or the URL I talked about, and the other one is the authentication key or the key attribute I showed you, right? So those are the two pieces of information. So from my exam perspective, if they ask you, it will be like, what are the two pieces of information that is important from a cognitive for usage of the cognitive service is basically the REST endpoint and the authentication key or the what we call it as an authorization token. Cool. So moving on from that, we will move on to our next module, which is exploring the fundamentals of machine learning. And then we will do the other two topics in tomorrow's session. It won't take much time. In another 30 minutes, I will be wrapping up. So if you are looking for like when am I going to finish, is it in another 30 minutes? So let me get back into my machine learning slides. Okay, so we are going to explore the fundamentals of machine learning. So I introduced you to machine learning already and a little bit to Azure machine learning. So we'll look at a little bit more around machine learning. And even if we finish it a bit early, we can wrap it up. That's not an issue. So what is machine learning? So suppose machine learning is all about creating predictive models by using the data and or finding relationships within the data. So if you take this example where a botanist, they are collecting some samples of flowers, and each of the flower has got certain characteristics. Like it has got the feature, like the color and the type of the buds it can produce, and then you have got okay, whether it is attached to the stem or not, what is the type of species it belong to. And then what you can do is you can use all those characteristics and you can design an algorithm, and basically like what it going to give as part of that is a model. So if you look at it, these are the different types of like samples of flowers, and now you are putting that into a thing and it is going to give me a machine learning model. And then which is basically like the human is going to label, okay, this flower is called this flower is called this, these are the characteristics of that flower. So they are going to label each and every flower. The machine is going to learn out of that, and basically what it's going to do is the next time when you give a flower, it will know automatically what it is. And that's what machine learning is capable of doing. So it can learn from the human, and it is going to be able to predict, or it will be able to just predict what it is going to be based on what it has been learned from the user. So machine learning comes in different types. So this is something you would have already heard when people talk about machine learning. They'll be talking about different set of things. So they will be talking about like supervised machine learning, unsupervised machine learning, and you may be wondering about what are these types of machine learning. So supervised machine learning is nothing but the training data includes labels. So in the previous example, when I showed you the flowers, right? So when we were training the flowers, basically like we will be training that with say what each and every flower is and what is the features are. When I say training, we basically do the labels for that. So let me show you a simple example. What does it mean? Um, So when I want to just try something, right? So I can just go ahead and create a model, and I can go ahead and do that. So let me quickly show you what does labeling mean, because that's an important thing to understand. Okay, so this is a simple, just to show you an example. So here you have the apples, right? So basically like labeling means like you take each and every image, and then you are going to say it is a red apple. It is a red apple. So you are going to train. So that's what labeling means. You upload 50 or 60 images for each and every image. So sometimes you may have an orange in here. If you have an orange image, basically you are going to say that it is an orange. And similarly, like depending on the type of fruit here, you will be like putting the labels, and then you are going to train the model. So what happens is your machine learning model is going to get trained based on the labels here. So it will say, oh, okay, so if I see the image similar to these characteristics, then it is an apple. If I see an image similar to the characteristics of an orange, because we have labeled it as an orange, it will automatically learn from that. And that's what we are talking here. And that's what supervised machine learning is, where you provide the labels, and the training data will include those labels, which means the machine learning is going to be able to do that. Unsupervised machine learning, on the other hand, is you are giving the training data and it is not going to be labeled at all. So what does that mean? So basically like if you want to like it will do some sort of grouping, so it will categorize things. I can see these images or of a pattern, say a common pattern, I'll group them together. I can see these images of a common pattern, I can group them together. It cannot exactly say what it is, like an apple or orange, but it can group them together in terms of certain characteristics. And that's what we call with the unsupervised machine learning, where the training data is not labeled, and the machine is going to learn as it goes along. So some of the characteristics, or what we call it as the types of supervised machine learning, is regression. So regression is basically you are predicting a numeric value. So if you take this example, right? So here, if I want to predict a price, if I want to predict how many ice creams are getting sold, if I want to predict how many bikes will be rented during this month. So they are all basically regression models. So you'll be creating regression models, but each regression model will have different type of algorithms you'll be using. But keep in mind, if you are predicting a single numeric value, it is a regression model, and it is part of supervised machine learning where you will be having training data that is labeled. If you do classification, so whether you want to say like, okay, you want to predict whether the patient is at risk for diabetes, like a yes or no type of thing, then probably you will be going for classification model. Again, this is part of supervised machine learning. So regression model, classification model, they are part of the supervised machine learning. And supervised machine learning is nothing but the training data includes labels, and regression is you will be predicting a single numeric value, whereas classification is basically you are predicting like it's like a yes or no or a ABC. You are classifying them into different groups. Unsupervised machine learning is basically the data is unlabeled, and it follows a clustering model. So as I told you, it will find patterns. So, oh, okay. So if you take cars, it can say, I can see these, the shapes are looking like together. So I'll group them together. Then it can do something like, I can see the shapes of the motor vehicle, like the scooters or something together. Or it can group in terms of like some are motor vehicles, or some are like petrol vehicles or diesel vehicles. Based on the emission type, it can categorize, because you will be giving the features also, right? You won't label them to say this is a diesel vehicle, this is a motor vehicle or something. So it can learn as per as it goes along, and that's what unsupervised machine learning is. It is going to categorize things based on some of the similarities that it can find between them. So this is what you will be training. So when you are doing like machine learning, so as I told you, the first thing you need to know, what is the problem that you are trying to solve. Am I going to predict a numeric value? Am I going to do some sort of categorization, or am I going to do clustering? Depending on that, you will be choosing between supervised or unsupervised machine learning. So what do you do after that? So as I told you, machine learning is an iterative process. So first and foremost, if you want to do machine learning, you need to have the data. So if you don't have the data, then probably like you won't be able to train things. So that's where you will be creating using the data in order to create your models. So if you are doing that, then probably like what you will be doing is like you create your data, you prepare your data, then you will be segregating out of the data, because you don't want to use all the data for training purposes, right? So you need some for training purposes and some for testing purposes. Normally what people do is, if you have 100% of data, they take 70% of the data and use it for training purposes, and they take another 30% of the data and use it for testing purposes. So that's what segregating between training and testing data mean. And then what you do is like they create the model, and then they will test the particular model based on the testing data that they have got. And then of course like they will deploy the model. So this is the typical machine learning process. So you get the data, you cleanse the data, you train the data, and then you you create the model, you train the data, and then pretty much like then you will start using it in terms of testing. And then you will be going ahead and deploying the model for other services or applications to use. So what does basically what actually helps you in terms of doing machine learning? Like for instance, like Azure Machine Learning is a service available on Azure that helps you to do the machine learning as we saw. So this is a cloud-based platform. Within an Azure subscription, we created a machine learning workspace. And within the machine learning workspace, which is the machine learning studio I showed you, you will be able to provision compute, jobs, services, data, and your machine learning models. They all can be provisioned in here. So there are three types which we saw, like the notebooks, the automated machine learning, and the ML designer. So automated machine learning is basically you supply the data and Azure machine learning will find the best model for you. So let us look at that demonstration in here uh, because I'm more curious to showcase it that. So this is the automated machine learning, right? So let us get started with an automated machine learning example. Okay, so let us do this one. So what we are going to do is we are going to just forecast the demand in terms of, like we talked about the bike data, right? So how much the bike data is really needed. So we can just use that as an example. So what I'm going to do is I'm going to show you like how we can go ahead and create the bike data set. So just give me a sec. Cool. Okay, so let us get started with our machine learning model. So I'm going to create a new automated machine learning job. So the first and foremost I have to do here, as I told you, like for any machine learning models, is to create the data set. So here I'm going to provide a name for my data set, and I will just call it as the bike data set. And then it is going to be a tabular model. And then I'm going to just take it from my local file. So here I'm going to upload files from my local. So just bear with me. I'll just go ahead and get my file. So this is my bike data that I have got. So if you look at it, I can start examining my file in here. So here I have got a comma delimited file. So I have seen the first has got line has got headers. So all files have got the same headers, which is good. And then I don't need to skip rows from anywhere. So it's all looking good. So now I'm going to examine the schema. One of the things that you can do is, like, if you want to just look at the things, like if you want to ignore certain things, you can go ahead and ignore certain columns. Sometimes you don't, if you don't want certain columns, you can go and change them. So for instance, here I don't want the registered or a casual column. I'll just ignore them from the training process, because if a column is not you're not it's not if it is not a feature that is going to help you with the machine learning capability, just go ahead with that. So now I can ignore those two columns and I say create the data set. So now my data set is getting created. Now I'm going to just select the data set and going to use it in my machine learning job. So what you are seeing here is like everything is simple. So I'm going to create a new experiment, and the experiment name I'm going to do is my auto ML for bike share. And the target column is I have a count column that is going to tell me how many bikes I can have. Sorry, it is there in here. And then I'm going to use the compute cluster. So here there is no clusters found. So I'm going to create a new cluster. So basically this is a machine where my auto ML model is going to run. So I'm going to create in Australia East, and I will use DS3 V2, like it's a 24 core machine. And then I'm going to use, probably I'll use more a CPU based machine. Okay, so it has got 24 cores, that should be fine. So then I'm going to just, okay, so then I can just go and say next. So here I'm going to give it my compute name. So I'm going to say this is my bike compute that I'm creating. And then I can have minimum cores and maximum cores up to 6 cores. And this is basically saying, like, if it needs additional cores, it can actually increase the, when I say nodes, basically number of VMs it can add to it. So then I'm going to just say like, okay, the rest are all fine, created, and this is going to take a couple of minutes. And once the compute is created, basically it will say, make sure that VM is available. Now I can use it in my compute. So the next thing is I have, what is the machine learning task type I need for my experiment? Is it a classification, or is it a regression, or a time series forecasting? So here it has already identified, because it's a bike share, right? So basically it needs to know what time of the day I have to have in there, like that will be used as for the forecasting method. So it has already predicted that. And I'm going to just say like, what is the time column? This is my date that has got the time information. The frequency is how often uh, like historic data needs to be collected. So I will use the default value for that. And now what I'm going to do is like, I'll remove the auto detect, and I will just going to say, this is going to be the length of time in the future I want to predict. So I would say like up to 14 days. And now I can just move on to the next. So the next is basically telling the parameters. So these are what we call it as parameters that I need to use. So in this case, the validation. Okay, so here, sorry, I think I missed something in here. Let us go back. Yeah, additional configuration testings settings, because here I'm going to just my primary metric I'm going to calculate is the normalized root mean. Don't worry about these things for fundamentals. Mainly I'm just saying, okay, these are the attributes that I need to put it in here. Uh, if I want to block any of the model, I can say don't use these models, because these are all the different models it is going to be training with my auto ML. You can, if you know, like there are certain models which your data scientists say don't try with these models with this data set, you can include them in there. And then if you have any exit criteria saying, okay, train the job for an hour, then after that, don't train anything. So now I have provided that information, and then I can just say like, okay, save this. And I don't need to provide any hyperparameters in here, because that's only for my computer vision. Now I can just say finish. So now what has happened is it has gone and it is going and creating an auto ML model for me. And now this process will take, if I keep on refreshing, it will get to know when it is getting started. And I need to leave at least for a hour. So it shouldn't take exactly a hour, but it will take less than an hour for us. And by that time, it is going to create, try different models, and it is going to provide me all the models in here. So tomorrow, when we come, I will be able to showcase it to you in terms of the models that got created as part of this process. So I will able to show you the output of this particular training. But that is the idea here. So, but here, if you look at it, I didn't write any lines of code. I just chose the data, choose the different configurations, and that was auto ML can allow you to do. So basically, you'll be able to create your machine learning models without writing single line of code. So the other option I told you is using the ML designer. So here you can just drag and drop, and you will be able to create your machine learning models. So the order of thumb rule I have got is like, I will take a problem. If the problem cannot be solved with automated machine learning, so that's the first thing I will be going. Then I will fall back onto designer. If designer can't solve my problem, then I will fall back on notebooks. So basically notebooks is where I will be going ahead and creating the Python code in order to build my end-to-end machine learning model. So in a summary, so what we learned as part of this module is we learned what machine learning is, types of machine learning, and what does model training and validation really mean. We looked at what is Azure machine learning, and also like the different types, which is the automated machine learning, Azure machine learning designer, and also when do you use notebooks. So the rule of thumb, always keep in mind your automated machine learning, if it can't solve the problem fallback is ML designer. If it can't solve the problem, then you go back to notebooks. But if you're a data scientist in your organization and you prefer writing everything using Python code from scratch, then of course you can go into notebooks and you can get started with that. So that's pretty much what I really wanted to cover as part of today's session. I know like I covered it without doing any break, and sorry for that. And but tomorrow when you come back, we'll also look at some of the things that we saw as part of the automated machine learning stuff, like how it completed and what are the models it created. And also like we will do a quick recap in tomorrow's session where I will post some questions. You'll be able to just respond with some answers. So I will get to know like how many of you like were attentive in the class. Sorry, it is going to be anonymous, so I'm not going to personalize anyone. So it will be really handy for you to learn. And in tomorrow's session, when you come, like we will talk about the remaining modules that we touched upon today. So one of the thing is going to be around natural language processing. The other one is a more detail about computer vision. So we scratched the surface of computer vision, but we will be going more in detail. And also I will show you like how you can use that API that we provisioned as part of the cognitive service to get information out of the images and so on. And thanks everyone for attending today. Hope it would have been useful for you. And thanks to see a lot of comments coming through. So if you come back tomorrow, then I will talk to you a lot more about things. I'll share some resources tomorrow. So Avinash, I looked at your question because it's a fundamental session. I didn't want to talk a lot about the models, the algorithms and stuff, but I'll share a bit more URLs tomorrow. So if you want to go deep into machine learning, you will have a bit of URL links that will be shared that will be useful for you. And thank you, everyone. And see you again tomorrow at the same time for the remaining modules of AI 900.
Thank you, Anvada, for the session. It was really entertaining and it was really resourceful. Thank you for the session and looking forward to tomorrow's session as well. And I hope you guys also had fun learning a lot about AI and machine learning. Yeah, so there is no attendance today. You guys can leave today's session and come back tomorrow the same time. It will be same meeting, same link, and same time tomorrow. And yeah, if you guys have any questions, please do keep it in the bucket and we can discuss it tomorrow with Anupama in more details. Thank you again,
Sure.
Anupama, for sharing your information, knowledge with the community, and thank you all for joining the today's session and see you tomorrow.
Thank you. And thanks, Rag. And yeah, looking forward to see everyone tomorrow again.